ideal, no? So what is the first of all, what is the cell? What idea we must have? I'll take you back to the basics here. This is the external resistance. Let me vary the resistance of this. Okay, fine, this one. So let the EMF of this be E. What do you expect the current? So it's having internal resistance. So let it be R, no problem. So what is the expression for I? I is equal to, so let me take time being ideal. Huh? So E by R, you're going to write. So as you vary the resistance, so what will happen to I? I will also be variable, no? So as I vary the resistance, the current also is going to vary. If you decrease the resistance, so here it should be like this. As I increase the resistance, current will decrease. Similarly, if you decrease the resistance, then the current will increase. What will happen to EMF? So let's concentrate on this EB. Whatever you vary the resistance, the EMF of the terminal voltage, it is going to remain same. So what is this particular, shall I call this cell what we designed or what we studying now? Shall I call this as like a constant voltage source? This term is very important. A constant voltage source is kept. So students will get confused. What do you mean by that constant voltage? Whatever parameters that exist, what are the conditions that can occur in external circuit, whatever the parameters that can occur in external circuit, the cell will see that the potential difference across it remains constant. That's why we call this as a constant voltage source, but current through it can be variable. Like this, we have constant current source. What is the constant current source? The current through the circuit will be variable, but the potential difference across that what happen has to change. So how do we represent constant voltage? Constant current source. So we do represent symbol like this. Then here what happen? The current I will be constant. The drop across this is going to change. It's a practically we can't design this. Only electronic devices what happen will behave like this here. There's a difference between the voltage source and showing constant current source. We show like this, circle with arrow. Of course, this symbol also used for ammeter, voltmeter, but they basically used for constant current source. We can't construct practically. Some electronic devices will behave like this, like a diode, transistor. They do behave like this. Here, what are the circumstances? I will be constant. VAB will be as you vary R, as R varies. R equal to what you can write it as VAB by I. So as R varies, the VAB is going to change. If R decreases, VAB decreases, but I will be constant. So these are the constant current sources, constant voltage sources. What we are discussing is constant voltage source. Whatever the conditions in external circuit, the cell will see that the drop across it, the EMF will be constant. The current through it is variable. Got the idea now? Okay, let's come for this. I think this is very important now. What will be the drop across AB? Should be called 4 volt only, no? But sir, here 3, 1 and here 3 volt is there, 1 volt is there, 4 volt is there. So what is a constant voltage source? Actually, these are constant voltage source, no? So what should be the VAB? VAB should be 4 volt. So directly our problem has become very simple now. So VAB, what I should do? I replace with 4 volt. What is the effective resistance? Now, this is very important. So without this idea, if I am writing that VAB 4 volt means definitely you should question teacher. What is a cell? What we have? It's a constant voltage source. Okay, I'll go for equivalent diagram. So in place of this AB, I should replace with a 4 volt. All that remaining everything. This will be 4 volt. Then again, this will come 4 volt. This is 2 ohm. This will be 3 ohm. And this is 2 volt. Now you can ask question, what happened? Why there is no internal resistance? Anybody? So let's go for RAB. How to calculate RAB? Any formula? 1 by summation of 1 by R, no? Let's analyze. 1 by 0, 0 ohm, 1 by 1 plus 1 by 2. All divided by, this will be infinity plus 1 plus 0.5, 1 by infinity. So what is RAB? 0. Got the idea now? Why I am replacing with only a cell of 4 volt? Why there is no internal resistance? Because I got RAB 0. Look at the mathematics. Is it okay? So nothing, we are not making any guess or imagination. Just we are sticking on to the basic things. So this should be that one. So now 4 volt, they are in series. The effective will be 8 volt. And this is 2 ohm. This is 3 volt. This is 3 ohm and this is 2 volt. So this is the point C. This is A. Now I think we can use the equivalent circuit formula. So let me assume this end A is positive. So EAC should be equal to 8 by 2 plus negative terminal of 2 volt is connected, no? Minus 2 by 3. All divided by 1 by 2 plus 1 by 3. 8 by 2 minus 2 by 3. This will be 5 by 6. 3 8 are 24, 20 by 5, 4 volt. Check one's calculation. Yeah, this will be okay. Now come for RAC. What is RAC? 1 by summation of 1 by 2 plus 1 by 3. So this should be 6 by 5 ohm. So what is the equivalent everything? The total thing should be equal to 4 volt, 6 by 5 ohm. This will be our answer. Like this, any number of grouping of cells, you can use this generalized method.
So can you please scroll the page up?
Okay, yeah, fine. Here, this one.
Yes, sir. Thank you, sir.
Completed? Okay, no, this next.
Yes, sir.
Okay, this is about the grouping of cells. So you can use this generalized method. How did we get VAB equal to 4 volt? So it's a constant voltage source. No, what is the idea? Constant voltage source. What do you mean by this? This I'm asking you to look here. Please look at this part. Constant voltage source. If resistance R varies, the current will vary. But what happened to the applied EMF? That will remain constant. This meaning of the constant voltage source. The cell is designed in such a way that the potential difference across it will remain constant. I think in all these things, I'm not like doing imagination, electrolysis, electrochemistry. When you study that, I think there you do, I have come across this one. When you design a cell, so what happened to the terminal voltage? What happened to the potential difference? The EMF will remain constant. That's what the electrochemistry, the Lachlan cell, Daniel cell. So there you come across this condition, no? Practically it happens. That's why we are putting that condition. It's not that like for our sake of syllabus, JEE Advanced means, okay, we are doing like this. Practically, the Lackland-Daniel cell, you fill up how to construct this electrochemical cell. You fill up electrolytic solution, anode, cathode. Then the terminal sort pen will be like this A and B, and you measure the potential difference, it will remain constant. But current through it can be variable when you start using in application. Got this? So VAB will be 4 volt. Next, maximum power, the last one. So if there is a cell